So before you start this section on identifying the functional groups, you should go back and review the properties of the functional groups, the structure, the formula, the examples that I gave you, because you're going to need that in order to be able to identify them. So in order to identify what functional groups are added, what you need to assume is that all these molecules are going to have carbons and hydrogens. So the carbon and hydrogen, the main backbone chain, that's not the identifier. What you want to look at is what's unique. So the question you should be asking yourself is, what is unique to this molecule? Is there something, else bonded to it? Is there a double bond? And that's going to help you identify it. So if we look at this first one, I see that we have some hydrogens and carbons here. This really isn't anything. That's just normal for all molecules. But if I look here, I see a carbon double bonded with an oxygen, then single bonded with an OH. And when I know my chart very well, I know that's characteristic of a carboxylic acid. So the only way to know the characteristic attachments or the characteristic formulas is just to study it. So if you go to the next one, remember you're looking at what's different. So what I see here is I see in 20, I see C's and H's, but right here I see a C double bonded to an O and then combined with another oxygen. And I know that's characteristic of an ester. So the next one, 21, C's, H's, but right here, the carbon is bonded with an OH, so that's going to be an alcohol. Again, I'm looking for what's different, looking for what's weird. So right here, I have a nitrogen. Now it is the NH3, which is characteristic of amines. Remember, amines, amino acid, protein. So really, as soon as you see the nitrogen is really characteristic of the amine. So really, as soon as you see that, you should know that it's an amine. And then the last one, written a little bit different, I have CH3, CH, and that's just, remember, it's like a combination of condensed and structural. But what I see is right here, a carbon double bonded with an oxygen, and that is a ketone.